This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Hello and welcome to a special Slooh show here live on slooh.com. My name is Will Gator, and tonight we're going to be trying something a little bit different, different from what we normally do here on Slooh. Tonight we're having a call-in show, so this is your chance to get in touch with us and talk to us directly here live on the show. So we've been asking you to get in touch with us all earlier this week and send in your questions, and we're going to be speaking to some Slooh members and also members of the public later on in the show. But look what we've got on screen. We've got live pictures here from the Canary Islands Observatory. You can see our dome there, and a little bit of a sort of hazy sky in the Canary Islands at the moment. There's a little bit of haze, a little bit of dust around. So we are actually going to be trying to bring you some live images tonight. What of? Well, tonight we're talking about comets. We're going to be talking about all sorts of different aspects of comets, from how they form, what they're made of, and even we're going to try and bring you some live pictures of the comets that are in the sky at the moment. So it's been an incredible year, hasn't it, for comets, really, and lots more to come. We've had Rosetta at Comet 67P, Churyumov-Gerasimenko, and we've had Philae land on the nucleus of a comet and send us back those incredible pictures. So there's lots to explore tonight, and we hope you enjoy this interesting sort of look at these really quite enigmatic objects in the solar system. They're often likened to these sort of unusual visitors that come in from the outer solar system. So we're going to be speaking live to some callers, and I think our first caller is on the line, and it's Christina. I wonder if Christina can hear me.
Yes, I can hear you, Will. Thanks.
Hi, Christina. Great to be speaking to you. I mean, comets, they're one of those fascinating objects. Did you have a question particularly about comets and the sort of things that you can see in the night sky related to them?
Sure. I have a couple questions that I collected from different members over the last couple weeks, actually. And one of the questions is, where do comets originate from?
Right. Well, I guess this goes back really to the birth of the solar system, really, doesn't it? It's comets. We like to think of them sort of. In some ways, you'll often hear astronomers talk about comets as time capsules of the conditions in the early solar system, and that's because really, in some way, they are relics from that period, many billions of years ago, when the solar system was forming out of this great cloud of gas and dust. And right at the very periphery of the solar system, we had the sort of cold, icy worlds forming, where we had these sort of almost like detritus left over from the planet forming process thrown out there into the distant solar system. And so comets really are these sort of fragments of that early period of formation in the solar system. Now, there are all sorts of different regions where different comets come from. So some comets are short period comets. They come from the Kuiper belt, and we hypothesize that actually there's a region far beyond the Kuiper belt, which is a sort of region right at the very edge of the solar system. There's a region even beyond that, sphere around the solar system called the Oort cloud, where there may be trillions of comets. So yeah, this really goes back to the heart of something that we've tried to find out for hundreds of years, hasn't it? Where do these comets come from? And in some ways, we're really only just beginning to find out. Did you have another question?
Oh, yes. What classifies a comet versus an asteroid?
That's a really good question. I guess some the scientists in some ways, astronomers are not completely settled on this question, I guess, because I think a lot of people, and certainly I think the prevailing opinion at the moment is maybe there isn't a sharp line between them. So if let's think back to something like the sort of progenitor of the Geminid meteor shower. It's an asteroid, technically, Phaethon, this asteroid that orbits the sun and passes through the inner solar system. And yet when it gets close to the sun, it sort of sputters off all these little particles and leaves a little tail behind it. And yet comets, we talk about these icy bodies that when they come into the inner solar system, they eject dust and gas. So yeah, I think I wouldn't like to say that there is a clear definition. Asteroids tend to be rocky and metallic. They tend to be distributed in sort of very clear places in the solar system that we know of. We have the main asteroid belt between Mars and Jupiter, and then there's different populations, some sort of held together by sort of gravitational resonances with the planets. But the comets tend to be much further out in the solar system. You do get families of comets associated with like gas giants like Jupiter. But yeah, I think what we're finding at the moment is actually that there's this sort of spectrum of different objects that comets and asteroids fall into, and that we're finding that some asteroids behave like comets. They give off little tails, and some comets sort of are very sort of inactive, almost like asteroids. Do you have any more questions as we're looking?
Years, I know that there were actually a couple asteroids that produced tails, and everybody was confused as to whether it was a comet or an asteroid, and I believe that they went back and forth about it. So that's why I wanted to ask the question.
Yeah, and we have this very strange sort of class of asteroids. Well, they say asteroids. They're actually known as the main belt comets. So these objects, exactly like you say, exhibit sort of tails, and it appears that they have these sort of interactions, and it might be due to collisions, but some astronomers think actually what we're seeing are these very icy asteroids in the asteroid belt. So yeah, it's a very interesting sort of area of this research, whether there is actually any real meaningful difference between them.
Okay, and then I have another question. Why are comets' comas different colors and shapes, and do some have more than one tail?
Yeah, so comets, if we think of a sort of beautiful picture of a comet, if we go back to say 1997, where we had that beautiful comet Hale-Bopp, and it had two quite clear different tails. One is a sort of whitish color that sort of sweeps up into the night sky, and another typically on that kind of comet is what we call a gas or an iron tail, and that's typically a little bit more blue, and that in many ways I think is what people think of as a comet. And yes, indeed, comets can have more than one tail. We have the component of the dust that is thrown off. That is so as the sort of solar wind sublimates the ices on the comet, as the gases come off the comet, it takes dust with it, and that creates a dust tail. That incidentally is what causes tails to be distributed in the solar system, so we get meteor showers, and then we get these gas tails as well, these ion tails. So yeah, comets can have more than two tails, and sometimes they don't. So sometimes we look at comets and we don't see a lot of dust emission. We don't, you might get a very thin ion tail, and sometimes you do get sort of very, very sort of inactive comets that don't have much of a tail at all. Well, Christina, it's been great speaking to you. I hope we've answered some of your questions, and I hope to speak to you again on another show. And good luck observing comets with Slooh.
Thank you.
Thanks, Christina. Well, we've got these beautiful live images here this lovely star field, and this is one of the challenges actually in astronomy, is finding where the comet is, because a lot of the comets that we're going to be bringing you live pictures of tonight, they're very faint. They're not the sort of thing that you could go out and actually have a look at. So this is why we have those Slooh telescopes, to basically take these pictures, these deep pictures, with telescopes that are positioned in perhaps the best, or one of the best places in the world to take these pictures, up on the top of a huge, essentially volcanic mountain in Tenerife. And so our next caller is on the line, I've just been told, and our next caller is Mary Lou. Mary Lou, great to be speaking to you.
Great to be speaking to you too, Will. This is a rare opportunity.
It's great. It's unusual.
Yeah.
I wanted
to say thank you to all. I'm sorry, the listening is a little bit difficult. I wanted to say thank you to all the members and the people behind Slooh for all the great astronomy shows you've been providing us with.
Oh, thank you. We love doing these shows, and we love bringing these live pictures. We always get a lot of reaction, a lot of feedback, and it makes it very worthwhile. Did you have any questions about comets? Because we're talking about comets this evening here on Slooh.
Yeah, I've really been looking forward to it. Yeah, I have a couple of questions. I don't want to repeat what the first caller asked, so I'm going to go on to asking you something about the comet's orbit when it comes close to the sun. Because of the icy nucleus, so do the comets shrink a bit every time they get close to the sun? And if so, how long does it take before the comet actually disintegrates to nothing?
Yeah, well, the answer is absolutely yes, because what we see as a beautiful sort of glowing comet in our night sky with that beautiful tail, that's dust, and that's material that's been taken off the comet. So it's been essentially, it sublimates it. The ices on the comet sublimate, so they go from a solid straight into a gas, and that motion creates that beautiful cloud around the cometary nucleus we call the coma, and in it is all this dust sweeping away from the comet, and so that's taking material away. So actually, if we think of something like Rosetta's comet 67P, Churyumov-Gerasimenko, there have been some recent studies. Because we've got Rosetta right next to the comet, we can really study exactly the sort of conditions that the comet is under. And here's the amazing thing. One of the results from the European Space Agency is that the comet that you're seeing in those pictures from Rosetta, it will probably lose, it potentially could use, some studies suggest, 20 meters depth off its surface in the course of one orbit around the sun. So that's kind of the first part of your question, and you can see from that an object that's maybe a few kilometers across. In the case of 67P, it's about 4 by 4 kilometers. That's going to lose a lot of material. So yeah, when these comets do eventually come into the inner solar system and make their journey around, they do lose material, and over time it's thought that they do, disintegrate, fall apart in some cases. We saw that with Ison, which came very close, didn't it? It's scraped by the sun. Right. So yeah, absolutely, comets do sort of, unfortunately, sort of deteriorate as they make this pass, because of course the temperatures they're under when they're near to the sun are quite intense.
Yeah, I imagine so. So then a comet could have a short life cycle, but it could also have a long one, for example, like Halley's Comet, which brings me to my next question. How come some comets have a repeat? So some we can predict and others we cannot.
I didn't quite catch your question. The audio just went out. You said, why do some comets have, and then I lost your...
Some comets, like Halley's Comet, have repeating orbits that we can kind of predict from year to year and know when to expect them, and other ones apparently do not. And why is that? Yeah,
so one of the interesting things you get with cometary orbits is cometary orbits, because they're coming in on these very elliptical orbits, they can often be strongly perturbed by Jupiter. Jupiter is an enormous, gas giant sitting out there in the solar system, and its gravity is, although we don't really feel it here on Earth, we don't have any sense of it as humans. If you're a comet coming in from the outer solar system, you pass by Jupiter or maybe one of the other gas giants, your orbit can be perturbed, and so that can change its orbit quite dramatically. And so you do get these families of comets that are quite short period. They're called the Jupiter family comets, and they're on quite short orbits. But then you also get those much longer period comets, and some comets are often, they might only be have observed once. So long period comets, we generally talk about them being over about 200 years to go around the sun. And so, in terms of professional astronomy, what a comet coming in from all the way out in the outer edges of the solar system, it might only be seen once in a human lifetime, even in the entire history of astronomy. So if you go back, hundreds of years, some of these comets will be out in the outer reaches of the solar system for literally millennia. So this is why we get these different comets in different orbits, because they're all coming from different populations. Some of them might have their orbits perturbed by the giant planets. Some might be coming from the Kuiper Belt region, so they have a slightly longer period orbit, and so they take longer to go around the sun. But then you've got these very sort of occasional visitors that come in from far beyond, that we only never get to see once. So yeah, there's a huge difference in all the orbital periods.
Yeah, there's all kinds. And I have one last question.
Yes.
And it kind of relates to one previous question the first caller asked you, but it's a little different. So because we're learning a bit more about comets from the Philae lander, I was wondering, is our definition of comets going to change a bit now that they're learning more specifically what materials comets are made up of?
I think that's a really interesting question. And I think my answer would be that we're going to learn so much from 67P, from Rosetta. It's going to be incredible, the way that we have this ability to both study the comet up close and then observe it here from Earth to get that sort of context. But one of the things we do have to remember is we're only looking at one comet there. And potentially, in our solar system around in the Oort cloud, there could be trillions of comets, and there are many thousands spread all around through the sort of closer in regions, in sort of the Kuiper Belt and in all the different comet populations. So we have to be careful about making assumptions based just on one comet. But I do think, on the other hand, that we're going to see a revolution in cometary science, because of the absolutely extraordinary work that Rosetta is doing and having that up close. So I don't think that we necessarily, will change our definition of comets, but I think certainly cometary science will never be the same after Rosetta and all the science it's done. Oh,
Well,
Mary
that's
Lou, I hope
really
that's
exciting.
answer your question.
Yes, it does. Absolutely. I'm going to take some of this information back to my middle school science class. I appreciate
Fantastic.
your time spending answering my questions.
It's a pleasure. It's a pleasure. Thank you for joining us here on Slooh. We've got lots of shows coming up on Slooh over the next couple of days. We've got a real packed program. In fact, we're not just looking at live images of comets tonight. On Wednesday, we're going to be looking at the New Horizons mission as it arrives at Pluto. A fantastic event, something that many astronomers have been literally waiting decades to happen, and we're going to have live coverage of that. We're going to have Clubhouse shows as well, so if you're a member of Slooh, you're not going to miss out. You're going to have extra special content in the run-up to that, and our live public show on Wednesday, July the 15th. And then we're also going to be looking at another asteroid, an enigmatic asteroid known as 2011 UW158. And it's one of those asteroids that scientists think, this might be an asteroid that we're capable of mining. Now, that's coming up on July the 19th, on Sunday, and so Bob Berman and Eric are going to be talking about that asteroid and what it is, not that we can learn from it, but also what we can get from it. Is it something that in the future might be something that we can use to explore our own solar system? So lots going on here on Slooh, fantastic program. But I believe we've got our next caller on the line now. We're talking live about comets here on Slooh tonight, and there on your screen is a beautiful picture, a little fuzzy coma there of a comet live from our observatory in the Canary Islands. But I believe now we can be joined by our next caller, which is Trisha. Trisha, great to be speaking to you tonight on Slooh.
It's nice to be speaking to you too, Will.
Did you have a question? that you
I have
wanted
a
to
few
ask?
questions, and hopefully you don't think they're too out there crazy. I know they've been sort of making headlines recently, but since we landed on 67P and we've been studying it, there actually was a recent headline that there was a scientist claiming that there were microorganisms on 67P, and I was wondering if what your response was to those claims.
Well, I think comets, we always talk about comets as being interesting in terms of astrobiology and the sort of the origin of life in the solar system and on Earth. But I think these particular ideas, this was a study, or at least a sort of result that scientists claiming that the features that we see on Churyumov-Gerasimenko, which is the comet that Rosetta is orbiting, they were indicative of being microorganisms on the surface. And I think it's fair to say that that's not really a mainstream view. Most scientists wouldn't take that as evidence for microorganisms. There are other processes at work. My personal view is I tend to side with the scientists. I don't think that what you're looking at there is concrete evidence for life, microorganisms on the surface of the comet. But that's not to say that these objects don't have any relation to astrobiology. In fact, we think that they're actually quite important for bringing important ingredients that we think go into life. So water is one of them. Perhaps actually it might be asteroids that brought most of the water, but certainly comets must have brought us a bit of the water to Earth. And of course, we need that for life. But we've also found other things on comets. So the NASA Stardust mission actually found an amino acid, what biologists would call a building block of life. And they found it on a comet. And we've also found other things, organic compounds all over comets, several of the comets we've studied, so things that contain carbon. So while I don't actually think that that particular study really is a sort of mainstream view, comets nonetheless are very, very interesting in terms of astrobiology.
So you don't think there are like little green men riding around on comets out in the universe?
I don't. Well, you know, I won't say in the universe, but certainly not in our solar system, and I don't think we have any evidence at all for that sort of thing. Even
Do
though
you
we have
think
this
that
lovely...
because we know that comets sort of contributed, or at least have evidence of sort of contributing to life on Earth, if we find comets elsewhere, we might be able to have them like point us in the direction of inhabited planets?
Yeah, well, recently we actually got evidence of a water-rich asteroid going into the atmosphere of another star. And that's one of the ways that you can actually study other solar systems, other star systems, look at the light from that star system, spread it out using a spectrometer to look at the sort of chemical fingerprints of that light. And you can actually see the chemical ingredients of what are falling into that star. And so we've seen that there was a water-rich asteroid in this other star system. So if there's water-rich asteroids in there, then maybe the rocky planets in that particular solar system, if there are any, they have oceans as well. Maybe they have water on them too. So we can make sort of deductions by observing other star systems, by looking for things like the dust disks around them. You know, are there planetesimal collisions? A lot of infrared astronomy is basically looking at dust in the universe, and that can tell you about things like whether a star system has something like our Kuiper belt, for example. And in fact, we do think that quite a few star systems have those systems. So, you know, there's a lot of evidence actually that there are other planetary systems out there in the cosmos, in our galaxy, that do have solar systems, star systems with comets going around them. They, you know, the evidence points at. So who knows? Maybe, you know, these processes are not just unique to our own solar system. Maybe they're going on in star systems all over the galaxy.
Very cool. All right, so I have one last question. And it's,
okay.
Now we're always concerned, and we, you know, Slooh has shows all the time about like near Earth asteroids and stuff. Are we ever worried about killer comets?
Well, I guess worried maybe is a bit of a strong word. Concerned, thinking about, yes, certainly asteroids and comets. You know, all of these objects that we don't know about, some of them that perhaps we haven't seen. Certainly, we need to monitor the skies and keep an eye on them. I think that's fair to say. I don't think we're worried about them necessarily at the moment. I think it's something that we really have to make sure that we're monitoring the sky and taking a sensible approach and making, you know, funding these surveys to make sure that we're looking at all different parts of the sky But I think, yeah, just as we think about asteroids, we should think about comets too, as potential impactors in the future. And you know, they're a very, in some ways, they're a slightly different sort of object to deal with. I mean, a lot of comets we think are incredibly sort of light, not very dense at all. They may just be sort of loosely held together. So when it comes to things like trying to deflect a comet, it might turn out that it's actually pretty difficult because they're essentially sort of loosely held together rubble piles, whereas asteroids, a metal asteroid might be a bit harder, might easier to hit, but might cause more damage. So comets, asteroids, yeah, we do have to think about them, but I don't think we have to worry about them. Does that answer your question?
It does. Thank you.
Okay, great. Well, it's been great to speak to you, Tricia. Thanks for coming on to speak to us live here on Slooh. I think as we watch these live images sort of rolling in from our cameras on the Canary Islands, we can sort of go to our next caller, who I believe is Paul Cox, who's Slooh's community manager. Paul, it's great to be speaking to you tonight.
Hello, Will, and you. It's been ages since I've seen you. I think it was that magical night, if you remember. Sorry, that makes it sound like a romantic liaison, doesn't it? It was that magical night back in March with the aurora from Iceland, if you remember that night. It's certainly going to live with me forever.
I do.
Hey, I love this format of show. We've got to do more of these.
I know we really do. If you don't remember, go back and look. If you're a Slooh member, go and look in the clubhouse and find the show we do with Paul, because we had Paul reporting live from Iceland, weren't you? Just as a coronal mass ejection and an incredible aurora display kicked off in the sky, and it was a real fantastic night. So really do, and if you're a Slooh member, go and find that broadcast. It's a great night. Paul, it's great to have you here. We're not talking about aurora tonight. We're talking about comets. And of course, this is something that Slooh is very, very involved with. We're involved with NASA, and I know that a lot of our members do a lot of fantastic work to sort of study these objects. What sort of things are we doing at the moment?
Well, nothing generates more discussion in the clubhouse than comets. There's one of the most active groups is the CATS Comet group, and they monitor comets. And, it's not just about science. It can be as basic as just collecting images over a period of months, over the apparition, the viewing season of a comet, and monitoring its tail and stuff like that. We're going to come on to this image. Look at this. This is something that generated a huge amount of discussion in the clubhouse last week. This is, as you recognize, Comet Lovejoy. But what do you make of this, Will? What do you make of that strange light in the top right-hand corner?
Now, if I don't know, is that an anti-tail? Is that what?
No, I think the anti-tail, we have got an image of that, because that once again is something that came up. But this, we believe, we're not sure. We've still got to do some processing of the images, but we believe this was an outburst of the comet, and it's then moved on and maybe left that behind. But so that's the kind of thing. It's monitoring comets because there's always something to see. There's the anti-tail, which is this brilliant image. So we see the main tail. This is only from last week. So this is Comet Lovejoy again, the main tail going back, and then this peculiar tail called the anti-tail going in the opposite direction. And when I first heard of these, Will, what causes these?
Sorry, the audio just cut out there, Paul.
I was asking, can you explain to viewers what causes these peculiar anti-tails and why they're only visible for a very brief period of time?
Yeah, so the interesting thing about anti-tails is that if you think about how a comet comes around in its orbit in the solar system, we always think about the tail sort of pointing roughly away from the sun, don't we? The ion tail points directly away from the sun, and then the dust tail sort of sweeps around. But all the time that comet is going around the sun, it's depositing dust particles into the plane of its orbit, so the sort of plane through which it passes through in the solar system. And what happens is, as we get to a certain viewing angle in the solar system, we pass through that plane, and then we're looking sort of edge on into all that dust that it's deposited, and we get this strange thing where it looks as if there's another tail growing out in the other direction, but actually it's a little bit of an optical illusion, isn't it?
Absolutely. It's all about geometry. And in fact, if anybody's interested, I put a little solar chart that shows that geometry of Comet Lovejoy last week while this happened. So have a look at that in the clubhouse. But you're asking about other things in the clubhouse that people can do related to comets. Now, monitoring comets, great, you can do that. Obviously, we've got this huge project, this Pro-Am collaboration, which is monitoring Rosetta's Comet 67P. And some of the questions that you answered earlier, you know, were really relevant to this. And us monitoring, members monitoring 67P every night is going to enable us to calibrate the images that we've been getting for years about comets, because Rosetta's there on the spot. So they're going to kind of calibrate our images and understand better what we're seeing in those images. But you can do anything from just collecting those images through to performing astrometry and photometry on comets. How about recovering comets? So these are periodic comets, which we know are coming back, but their orbits are never that precisely known. So one of the great things that members can do is be pointing the telescopes every night to roughly that location and go on the hunt for returning comets. So you get named as the person who recovered comet X, Y, or Z. The other great, really great one that some members have been doing over the last year is making the first confirmation images of discoveries. So these are potential discoveries. They get notified on the internet, and members quickly, and that's because of the way Slooh works, can very quickly, within a few minutes, if they've got a mission booked, point the telescope to that potential comet and grab the first comet confirmation image. And also, some members are still on the hunt, Will, to make a comet discovery. Now, we haven't quite got there yet with Comet Slooh, but we're going to. I can feel it.
I think what the lovely thing I always think about talking to you, Paul, is your enthusiasm. I think that really does sort of sum up, you know, what's going on in the clubhouse. You've got all these fantastic teams of people working together to do real science, and this is the thing, and it's what you're saying earlier on about, you know, calibrating what Rosetta's doing. But you know, this is your chance to get involved with what the real scientists are doing. They need to know the context of what's going on with Rosetta's Comet 67P, and we can do that here with our telescopes on Slooh and in the Canary Islands. Paul, thank you so much for coming on and sort of giving us the sort of insider perspective. It's great to speak to you, and I'm sure I really hope we catch up soon on another show, and we'll find out what the Pro-Am teams are doing.
Can I ask one thing, Will? Unfortunately, Christina Feliciano, who's running the 67P Pro-Am collaboration, the group in the clubhouse, she didn't get a chance to ask this. So I'm going to ask it on her behalf. It's community members. It's not just about using the telescope. Community members can get involved in this stuff as well. And Christina is looking for anybody, including community members, who can take some of the images that members are taking of 67P, do a little bit of processing, put the frames on them and the titles, making sure everything's absolutely perfect before they're then submitted to the group. So if there are any members out there who maybe, you know, are okay at doing a bit of light processing in Photoshop or something like that, please go to the 67P group and volunteer to Christina. She will be very, very pleased to have your help on that one. Sorry to delay the end of the show, Will.
That's fantastic. It just shows how there are all sorts of different ways that you can get involved with what they're doing. Paul, thank you so much for speaking to us.
Pleasure.
That's the end of our show. Thank you so much for tuning in, and thank you to our callers who asked questions. As I said earlier, we've got a fantastic lineup of shows coming up this week. On Wednesday, we have the New Horizons. As it arrives at Pluto, we'll have interviews with scientists, and we'll be finding out what it is about this enigmatic dwarf planet that scientists really want to understand. Then on Sunday, July the 19th, we're going to be looking at that fantastic $5 trillion asteroid, the asteroid that some planetary scientists and some entrepreneurs want to mine and see if we can actually use as a resource in our solar system. So lots happening here on Slooh. Thanks once again to everyone who's called in, and thank you for watching. We'll leave you with this lovely live view from the Canary Islands of our Milky Way rising there over the domes of Slooh. Thanks very much for watching, and we'll see you again next time on Slooh. Good night.